Hi, and welcome to our second lesson in Chapter 2. Today we're going to be, and tomorrow, we're going to be looking at how to display distributions graphically. So we'll be reviewing some graphs that you know a little bit about. We'll be doing some that you know a lot about, and we'll hopefully show you a few things that you didn't know. So the best way to describe a distribution is very often by shape. So you really need the visual of a graph to do a good job at deciding about what a distribution really is doing. We're going to look at three types of graphs today that are suitable for numeric data. And then tomorrow our focus will be on categorical or non-numeric data. Our graphs today, the dot plot, which we already have had some experience with, the histogram, which is the statistician's favorite graph, and stem plots, which are also called stem and leaf plots. You may remember those from your algebra class. The data set below, totally made up by me, shows the number, it says, of indoor pets in 25 students' homes. So we have several homes that have 0 pets, some that have 1, some that have 2, one that has 8. So we're going to create a dot plot for this data, and I'd like to remind you of a couple things before we begin. First off, don't forget the basics. Every graph has to have a title, labels, equal spacing, etc. We know the rules for this, so we're going to ask you to keep that in mind. And with that said, let's add those things here. Equal spacing, well, we do have some on our number line that have 0 pets. I've tried to make those hash marks close to being the same. I know they're not identical because I'm not a machine, but they're pretty good. And our graph is going to have numbers of pets from 0 to 8, dot for each pet above. We need to have a title for this, so I'm going to write it over here on the side, number of pets in the household, and the dot plot, of course, puts a dot above each for each data value above the appropriate number. You should try and be uniform as you're spacing them upwards too. 1, 2, 3, 4, 5, 6 zeros if I'm counting right. So 1, 2, 3, 4, 5, 6. We have 4, 5, 6, 7, 8, 9, 10 ones. Now it's going to get a little cramped in there. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. We have 1, 2, 3, 4, 5 twos. We have 2 threes, a 4, and an 8. And ladies and gentlemen, if we had to describe the shape of this distribution, I hope that you would say that is skewing to the right, stretched out toward the right, because of this one outlying value, or at least extreme value. One household with 8 pets, that's many more than any other had. The dot plot is good, folks. I want to show you why dot plot. So we'll go here. Dot plots work the best when you only have a few data items. You can see it would be very cumbersome if you had more than 20 or 30 dots or so. When you want to see the individual items, notice that I can tell just by counting how many households have each number of pets. If we put that in a bar, that would not be apparent. When you want to see the shape, as in the skewedness, you definitely like a dot plot. That's a good one for doing a quick visual. And if you want to compare a few groups. Now you'll remember we did use some comparison dot plots back in our first chapter where we compared, I can't remember what the situations were, something about West Vaco. We've got experience with dot plots. We're pretty happy about those, and they're a good, quick little graph for us to learn on. Our next graph is the histogram, probably the statistician's favorite graph. This is the one you see most frequently. Histograms are used to show frequency. The y-axis is always labeled the same thing here, frequency. And what happens is you decide as the statistician, as the grapher, how many bars, or bins is the technical term for that, you want. You can group together several x values, but you have to use bars that are the same width always. It says then that you set up a number line for the x-axis. Well, let's go ahead and do that. Our data ranges from, and by the way, totally fictitious, but I made up ages for teachers here. With a high at 56, and no, that is not me. A low of 23, and that gives us a spread or a range in our data of 33 years. We need to get that set up into equal chunks. So this is what I'm going to do. I'm going to make 6 bars. And what I'm going to do is show a break in my number line. I'm not starting at 0. I'm going to make 6 bars. So 23, if we divide 33 by 6, that's going to be 5 and some. So that means we're also going to be 6 wide. So 6 bars of 6 wide. 5.6. Which is close to 6 years, and we're going to go to 6 years. So 23 plus 6 is 29, plus 6 is 35, plus 6 is 41, plus 6 is 47, plus 6 is 53, and 1, 2, 3, 4, 5. Yep, one more. The upper limit on this one would be 59. Of course, we know we don't have data that tall. However, that's the way we're going to mark it. The label down here would be age, and the title, Ages of Teachers, would be fine. Let's see how many fall into each bar, because that'll tell us about how high we have to make our y-axis. Between 23 and 29, we have quite a few, folks. 3, 4, 5, 6, 7, 8, 9, 10, 11. So really 29 should go with the next one. 10. We got to go 10 high, and I know that's going to be our tallest bar. So I am going to number by 2s here. 2, 4, 6, 8, and 10. And my first bar has to be 10 units high, because there are 10 teachers that are at least 23 but less than 29. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's right. Between 29 but less than 35, we have 1, 2, 3, 4. Notice no space between the bars in a histogram. You lock those things right next to each other, because, you guys, this is a number line down here. From 35 up to 41. So 1, 2, 3, 4, 5 there. A little bit higher. 41 with an upper limit of 47. 1, 2, 3, 3. 47 to 53. Let's see. 1, 2, 3, 4 there. And finally, between 53 and 59, we have 2 teachers that fit into that category according to this fictional data. Excuse me, there's our histogram. We've grouped the data into classes or bins that are 6 units wide. We have 6 bars. Experts say 5 to 8 is good. If we had more bars than 8, folks, it gets very, very crowded down here on the x-axis. And if you're going to do that, you might as well just do the dot plot, okay? If you go less than 5 bars, what you end up doing is pushing groups of data together until you kind of lose shape of the what does the data set really look like. You can tell in this one that we are skewing down toward the right. Okay? We want to be able to see that. I want to pull out my checklist here for histograms for you and say this is why and when we would use them. Histograms work well when there are a large number of values to plot, okay? And you can see that here. I only have 6 bars, but that's representing 33 data values. If I don't need or want to see the individual data values, again, if I wanted to see them, I'd do a dot plot or some other that shows us individual data values. If we only need to see the general shape, it's enough to see this. You can see from here that this thing is skewed toward the right. General shape. And the nice thing about histograms is you can use a calculator or computer software to make them, and that's where we're going to head next. So I am going to go to the next page, and I want to call my calculator up because I want to show you the histogram that I made. I have a window set up, and this is the teacher data, the teacher age data, and I made mine. I'm going to show you the window screen. have an X scale of 1, so 1 bar for every age from 20 to 60. And again, I'm going to say that is too crowded, okay? That is way more stuff down there than I want to wade through. To get a histogram like this, I will show you the steps and I will write them here. You can also see them in the separate histogram video. To set up a histogram, you need to have data in lists. That's stat and enter. I have the teacher's ages entered in list 1. The next step is to go second and y equals. This is where statistical plots are. You can see that we have the capability of doing 3 on this calculator. I'm going to go ahead and hit enter on my plot 1 settings. If you need to change anything here, you want to make sure that your graph is turned on. So with the cursor on, hit enter. Histogram is the 3rd in the type line. The X list by default will go to list 1. If you want to change it to a different list, you certainly can do that. And the frequency is by 1. That is, we're using each element in list 1 one time. Then to set up a window, our data set started with a 23, so let's make that y min 23. So I'm going to make my X max 59, the same that we had on the previous graph. We want it to look like that. An X scale of 6 should do that for us. We have a Y max of 15, which is plenty. We needed 10. Let's see if we've got something that looks like ours. Yep. 1, 2, 3, 4, 5, 6 classes or 6 bins. Good. Now, I want to write down some calculator tips, and then I quickly want us to think about how we can change the appearance of this graph. To enter the data values into a list, folks, it's stat and enter. To enter the plot settings, that was second and y equals. To set an appropriate viewing window, ladies and gentlemen, lower than your lowest, higher than your highest is a way to go. If you don't have a good idea, you can always use Zoom 9. That is a statistical fitted window. I want to show you that here. Zoom and 9, it reads your data and sets up what it says is the best. 1, 2, 3, 4, 5, 6, 7 bars they like. Okay, and it was just that easy to change right there. Did you notice that? To view the graph, you just press the graph key. And I'd love to have you take just a quick look, one more look at the calculator graph. We can really change the appearance of this thing, folks, by changing the width of the bars. I want to show you what happens when we change this and make it 10, okay? Which means we're clumping lots of data together. Look at that. We still see the skewedness, but this bar is right off the chart. 10 is probably too wide. That's only 4 bars in the histogram. Not enough. Okay, 5 to 8 is what the experts say. Oh, I want to go back there for just a minute. Yes, you'll notice when I push the trace button, what it's showing me is a lower limit and an upper limit. So from 23 to 33, there were 14 data items. And I can go right across my graph, just hitting the left or right arrow. My next bin here had 5 elements in it. I showed you when it was too skinny. Now I've showed you too wide. I think we've covered that. I'm going to go back there and make it a 6 that I like. And go ahead and hit graph again. All right, there we go. Let's go on. The last graph that we're going to look at today is called a relative frequency histogram. Folks, that shows a relative frequency is really just a percent or a proportion. It shows the proportion of the data that falls into an individual bin. Any histogram can be changed to a relative frequency histogram by, and I've got it here, dividing the number of items in the bin by the total number of data pieces. Folks, that's easy to do if you're by hand. It's hard to do if you're on the calculator. So if you're called to make a relative frequency histogram, by hand is the way to go. By the way, since we're not changing the ages here that are in our bins, we can go by the same 23 and up by 6s, 29, 35, 41, 47, 53, and 59 is what we had. So the ages of these teachers don't change. What does change is the y-scale. Instead of going from 0 to 10 for the number of teachers, now we're going to go for percentages. And we should probably start at 0%. And I'm going to go, I think 40% will be enough. 10, 20, 30, 40. And from memory, I know we had 10 items in the first bin. Oh, I don't know the total. Shoot. All right, we had 27 teachers in total, and my first bar had 10 in it. Okay, ladies and gentlemen, what I did was go back to the page where we graphed previously. I counted the number of items in each bin. To get relative frequencies, I divide by the total, and we had 27 teachers represented in total. That gives us about 37% for our first bar. Again, just guesstimating when you're doing it by hand. 15% for the second bar. 19% for the third. 11%. 15%. And 7%. You should notice, I hope, you still see the skewedness here. It's just that we've scaled the y-axis differently. When you change that frequency into relative frequency, you did not change the shape of the distribution. It stays the same. So no, it doesn't change. Doesn't change shape. The only thing you're changing is the y-scale, how you're counting those teachers. All right, we're ready to make a stem and leaf plot of our teachers' ages again. So we'll see the same data displayed differently. Some of you will remember the stem and leaf plot from your algebra class. Let me just quickly go through these things. Stem and leaf plots work really well when you have a single quantitative variable to plot. You wouldn't want to try and plot two numeric values, two differing numeric variables on a stem plot. That would not make sense. If there are relatively few data items, if you still want to see the individual items and to see a shape quickly, it's also possible to make a quick comparison of two groups of data, same measurement from two different parties maybe, by making a back-to-back stem plot. Page 48 in your textbook shows a back-to-back stem plot. But let's us do this stem plot. I gave you some hints down at the bottom. The tens digits will be the stems. That is, what you do is look at your data set and say what's the biggest place value that they all have in common. These all have the tens digit in common. So we're going to use the tens for our stems. The ones will be the leaves. And it says that we should include a key. Don't forget a title, okay? Because this is a graph. It deserves a title. So these are teacher ages. And what we are going to do is write down the tens digits. We have people in their 20s, 30s, 40s, 50s. Okay? Then we are going to, and if you were a real stickler, you could draw yourself a straight line there. I'm going to just try and write across. We have the tens digits down. Now we got to put the ones. So we have a 3, 2 4s. Some people put commas between them. Some don't. 2 5s, 2 6s, 2 8s, a 9, and then we hit the 30s where we have two that are 30 exactly, a 31, a 35, a 6, an 8, there are two of them, and then we're at the 40s. We have a 42, a 44, a 46, 48. I'm going to skip to the end of this so you don't need to hear me count through all of these. Now, we have a completed stem plot here, except we don't have a key yet. A lot of people are not used to reading a graph like this, so you really should include something like this that says 2 bar 3 equals 23 years old, just so people know what's going on there. It's not a graph that's well known to the general public. So, do you still see the skewedness here? Well, sort of. You can see it's getting smaller. The number of numbers are getting smaller in each row, and that is an indication of skewedness. One thing that you could do, and that your book shows, if we thought we had too many 20s on this line, for example, some people make a second line, or maybe they would do this, 20 and then a line for 25 and above, 30, 35 and above. Your textbook shows a couple of examples of that as well, so I will let you look at those. All right, I believe that does it for me today. I've got my stem and leaf plot, I've done the histogram, I've done the dot plot. I think we've covered them all. So it's up to us to get out there and try that. You try as quickly as you can, and I will see you in school. Bye.